If you're a retro-futurist cyberpunk like me, it may be easy for you to imagine getting into your DeLorean and going to the year 2050 to bring back a sample from the barrel of tomorrow. And it will probably look like this: carbon negative, made with biology, and biomanufactured by microbes. But future isn't something that just happens because time goes by. It's something that we create. And for the past 7 years at Cemvita, we've been creating the future hydrocarbon feedstock for energy transition. This feedstock, of course, could be used to make a wide variety of molecules and end products. But there is one in particular that we're focused on, and that's sustainable aviation fuel. The work that we do is actually anchored by a 20-year contract with United Airlines for us to supply United Airlines with 1 billion gallons of sustainable aviation fuel. Now you may ask, why would United Airlines, the biggest airline company in the world, make such a big bet on a small company like Cemvita? Well, it's because we remove their biggest bottleneck, which is feedstock for SAF, as Michael Leskinen, CFO of United, points out here. It may be a surprise to some of you that today we make SAF using these feedstocks. Used cooking oil, animal fat, and also vegetable oils like soybean oil. These are used in a process called HEFA, hydrotreated esters and fatty acids, and turned into SAF. Now the problem is, these feedstocks are just not scalable. You can't wake up tomorrow and say, you know, I would love to have 10,000 more restaurants making French fries. And even if you think about vegetable oils like soybean oil, these are agriculturally derived. So on one hand, you have the food versus feedstock debate, which is still very legit. And you also have this environmental penalty. Think land use, water use, fertilizer use. This is our situation today, the status quo. And that has led to the fact that only 1%, actually less than 1% of the aviation operational capacity is SAF. So the question is, how do we grow SAF capacity sustainably? Enter Cemvita's sustainable microbial oil. We've been able to genetically optimize and engineer microbes that use waste carbon as their feedstock and produce an oil profile similar to soybean oil. If you look at the image on the right side, that's under a petri dish, our microbes. And the droplets that you see inside each microbe is actually the oil. And it's up to 60% of the cell weight. You could even see it visually. So this oil smells, tastes, walks, talks, dances just like soybean oil. And here's data from third party showing that match with C16 and C18 compared to soybean oil. This is not just an experiment in the lab. Over the past 3 years, we've been able to scale this production for up to 55,000 liter capacity in our pilot plant right here in Houston. And with that, we produce gallon-size scale of the oil that we send for testing. And I'm happy to say, just as of 2 weeks ago, we also now have a site selected for our commercial demo plant, which we'll build in collaboration with our long-term partner, Oxy. So SAF is just the beginning for us. It's just one end product. We're really in the sustainable feedstock business. So that oil you could use for different end products. Could be a bio-naphtha turned into ethylene. Could be other high-value products as well. William Gibson said that the future is actually already here. It's just not distributed yet. So I hope that today I could share with you not just a vision for the future, but also a future that you could hold in your hands today at the break here in a few hours. Thank you.
Thank you. That was really exciting. So I guess first question for me is, where does the CO2 come from? When you, I guess, plan to scale, you're thinking about your first demonstration project, are you looking at kind of capture from the atmosphere? Are you buying it from point source solutions? Where are you getting it from?
Yeah, we really are not agnostic to the source, and that's really the beauty of the microbes. They're quite flexible. We've actually tested from 2% CO2 to 60% CO2. Currently, most of our work is based on industrial source capture, but really the vision is to couple this technology with Oxy's 1.5 direct air capture and use that as a primary source for CO2 utilization.
That would be very cool, because I guess there's a big value in having a carbon negative fuel as opposed to one coming from, or carbon neutral rather, one coming from kind of, I don't know, cement emissions or oil and gas emissions.
Absolutely.
And SAF, so when we first met a few years ago, I think your focus was a bit more on chemical side, and obviously you mentioned that's still a strong focus. Kind of why SAF, I suppose, because that's more of a low margin product, right, than chemicals?
Yes, in the range of things, and you could imagine we could make the same oil and sell it to Whole Foods as, olive oil or something. Yeah. But we're technology people in Houston, passionate about energy transition, wanted to have an impact. So it's not just about what is the best margin, but the size of the problem is such that there's a huge market for sustainable feedstocks for SAF. Also because I believe that right now there is a massive over-indexing just for measuring the carbon intensity of feedstocks and ignoring the impact on the environment, such as biodiversity. I think that it's going to put a much bigger strain on agriculture-derived feedstocks. And so we want to leverage the latest and the greatest of synthetic biology to provide a different solution.
And you're making the soybean oil equivalent, or your vegetable oil equivalent. How does that get to your aviation fuel? Are you going to do the upgrading yourself? Will you sell it to United and they do it? Will you contract a hydrotreatment facility?
Our view is to tackle that space as with the JV, the collaboration. So we're not going to be like a Cemvita, Cemjet, similar to LanzaTech and LanzaJet. The HEFA part of this process is something that is very established technology, and we have some of the best partners in the world, so we just plan on leveraging their expertise and use the talent of our team just to focus on actually making sure the microbe is doing their job and producing the oil, and the rest is just collaboration.
Yeah. And finally, what are the biggest challenges for you in the next couple of years when you look towards commercialization, besides, I guess, raising the money, but like technically, what are the challenges for you with your technology to scale it?
Yeah, I mean, there's no shortage of challenges, but I think part of it is actually logistical planning, because we need to choose a location where we could have access to our feedstocks, but also that they could deliver the end product to the parties, and for that to make sense. And so securing offtakes on both ends is not a trivial effort. The person that runs that at Cemvita, Phil Garcia, he joined us from Neste, so we call him Mr. Feedstock. He just knows the map just off the top of his head. The second part is we're basically leveraging all the learnings from the biofuel era and applying it to what we do. So as part of that, we have some new designs. You may have seen in one of the pictures this new plastic, actually, bioreactors. And so we've just, in the end of figuring out what they're going to look like. Are they going to be tall and skinny? Are they going to be, shorter and just wide? And that changes a whole bunch of other engineering parameters. So we're feeling pretty good about that one. And then, of course, the financing is always something to consider along the way. The good news is that we feel really great about the microbes and what they're doing. The processing, the downstream, the lipid extraction is still doing more R&D on that and see what is really the best method.
Yeah, but the hard thing is the microbes. So that's the IP, right, that you've been working on. Wonderful. Thank you so much, Moji. This is really interesting. Thank you for your time.
Thank you.
Yeah, if you go this way, I'll keep this.